Microneurography is a research technique used to measure electrical signals sent down nerves in the body. Specifically, sympathetic microneurography measures activity of sympathetic nerves, which are involved in the fabled flight or fight response. In order to measure electrical activity in your nerves, your experimenters need to find an accessible nerve which is close to the skin and, when stimulated electrically, produces observable twitches or sensations. The common fibular or peroneal nerve is a good choice for this technique, as it runs close to the skin and can be stimulated quite easily for twitches. First, your experimenters will secure your leg to minimize its amount of movement, so try and keep it as still as possible, as your experimenters are trying to finely guide an electrode with a width of less than 3 human hairs into a nerve, and movement can displace it of course, or move the electrode completely. Next, they will try and find the nerve in question, and they'll do this by palpating around the nerve and asking if you feel any pins and needles sensations. After roughly mapping it out, they'll use an external probe with some conducting gel on its tip to deliver some weak electrical pulses through the skin. There'll also be an anode attached to the opposite side of the knee, so current passes directly through the knee. They'll probe around the nerve until they find a site where they see strong twitches or pins and needle sensations, and they'll regularly ask you what sensations you are experiencing. Microneurography is a slow procedure, and your experimenters may take a while to probe and find the common peroneal nerve. Once they find a site, they'll mark it, and then they'll use a recording microelectrode to pierce into the site. They'll then use a head stage, which is a metallic-looking tube that allows them to amplify the signal and allows them to connect several electrodes, which they will tape to your leg. A ground surface electrode will also be connected to your foot, as well as a reference microelectrode placed about a centimeter above a recording microelectrode. Something to note though is that the microneurography needle itself has the width of, again, less than 3 human hairs and is so fine that it is often neither noticeable nor painful. They will then guide the microelectrode tip into the common peroneal nerve by systematically adjusting its depth and its angle whilst delivering weaker and weaker electrical pulses. A nerve contains fascicles, each which supplies a different patch of skin or muscle, and your experimenters are trying to guide the microelectrode tip into one of these fascicles, and they'll know they've reached a fascicle as they'll keep lowering the current they deliver, and if they still observe muscle twitches or pins and needle sensations at a current of less than 0.02 milliamps, they'll be confident they've inserted the microelectrode tip into a fascicle. A word of caution though, this procedure is long, as finding the nerve and inserting the microelectrode into a fascicle requires precision and takes time, but the procedure itself is safe. As Professor of Neuroscience Vaughan Macefield, who's been doing microneurography for 30 years, explains, we always inform the participant that they may experience some transient discomfort lasting less than a second, as the microelectrode is advanced during intraneural stimulation, but when they see their muscles twitching, they invariably laugh. With the microelectrode within the fascicle, your experimenters will then observe electrical signals of the common peroneal nerve, which they can convert into an audio signal so that they can hear the bursts of electrical activity. They also may ask you to hold your breath to enhance the sympathetic activity. Since your experimenters are inserting a fine electrode into the common peroneal nerve, there may be some minor inflammation of the nerve after the procedure. Therefore, it is advised that you don't engage in any strenuous physical activity, such as running, cycling, heavy lifting, 24 hours after the microneurography experiment. But after 24 hours is up, you're good to go.